Hi, welcome back to DevOps presentation series unit 2, and we are discussing about architectures. In this presentation, I am going to talk about monolithic architecture. Let's go to the next slide. Monolithic architecture. A monolithic architecture is a traditional and a common approach to building a software application where all components, also known as layers, of the application are bundled together into a single indivisible unit. In a monolithic architecture, the entire application is developed, deployed, and run as a single process. So before going to the characteristics, let's talk about the definition of monolithic architecture. There are two things I'm repeating, like layers and tiers, right? Are they same? No, actually no. Layers and tiers are two different things. Also, there are two kinds of architectures, layered architecture and tiered architecture. I'm going to talk about the differences little later, but once I go to the um, next presentation. But just understand that layers are different from tiers, right? So now in a monolithic architecture, again, like I said in my previous presentation, there are three components, right? Front end, middle tier, back end. So in monolithic also there are three components. There are three different things. However, they are kind of layers. Like this is front end, this is middle tier, this is back end. Like that, they all bundled together into one single unit. So there is a distinction, but that distinction is not really well defined, in the sense that front end could directly talk to middle tier, or it could talk to back end directly, vice versa, right? So but for the sake of development, they are going to be there present in three different components. But again, they are really connected together. Now, when it comes to development, and the same team work on all the three parts: front end, middle tier, and data access tier, or front end layer, or middle layer, or the data access layer. So all the three components work with the same team, and when you compile, you will get one single file, one exe file, or whatever it is. Again, when you build it, there is one ISO file, and when you run it, the entire application runs as a single process. Like all three things are going to be run as single process. Means there is no separation of these three things, right? So that's what it's about monolithic architecture. I'm going to show a picture in the next slide, but let's go to this characteristics. Single code base. So first characteristic is single code base. All the code for the application resides within the single repository or the project. So there is going to be only one project. In the project, we have maybe three directories: client, middle, back, and so whatever it is. And there you write the code. But it's one project. And the entire code repository is only one. For this entire project, there is only one repository. Unified, most of the time, the technology used is the same across all the three layers. That means front end, let's say we are writing an application in Java. The front end is in Java, the business logic is in Java, and the database access layer also is in Java. So all the three things are using one language. So that's how it is unified technology. So built using a single programming language, framework, and set of libraries. So layered architecture. So this is very important. Monolithic architecture is a layered architecture. Not a tiered architecture. It's a single unit, but organized as UI, business, and data access layers, plus a database. This is also very, very important. Even though there are two things here. One is the software, the code, and second one is the actual database where things are stored. Database is not part of the code. It's a third-party thing always. Database is also third-party thing. So when you talk about code part, it is the UI, business logic, and the data access layer. Now, there could be a small confusion between data access layer and the database. They are not same. Data access layer is the code part that is used to access the database, right? That is the data access layer, or the connect to the database, get the data, write the data. This is the thing. This is the guy who handles the database accesses. Middle tier is the business logic, which we talked in the previous presentation. And front end is front end, right? You enter the input data and stuff like that. Single deployment unit, that is another characteristic. The entire application is compiled, packaged, and deployed as a single executable, or ISO file or RK file. So we already talked about it. And shared resources. This is also very, very important. All layers share the same resources. That means since we already said that the entire monolithic application is going to run as a single process, that means it's a single exe file. I mean, if you think it's a Microsoft program, so where all the three types use the same CPU, same RAM, all that stuff, right? So that's pretty much like one big bundle of things, right? So that's what monolithic application. Let's see the architecture diagram. Now here, here you see that browser or OS. So this is where you start the application. If it is an exe application where desktop based application, you start the application by double clicking or typing a command at the command window somewhere, like mostly, right? Or if it is a web based application, use a browser. You start the application. Now sometimes you may want to have multiple instances of the application, because one instance goes down, another should work, or there is a lot of traffic, you want to cater to multiple things. That's where we use a load balancer. A load balancer, by its name itself, it tells that based on the throughput or the number of inputs coming, a load balancer will channel it to the number of instances that are available. That means this entire thing is one application. This is also another application. The same application, another instance, basically. So same application, there are two objects of the same instance of the same applications. Now what load balancer does is that when somebody wants to use this application, it will either connect to this guy or this guy, based on the load on this application or this application. Again, you see that all the three are connected to the same database, right? And you can see that the entire instance contains this presentation layer, this application layer, and the data layer. Again, this instance also, again, this is same application, two instances, right? So you have the same things here. So instance 1, instance 2, and they are being load balanced with the load balance. That's how monolithic architecture works. Right, let's go to the next slide. Now, pros and cons of monolithic architecture. There are advantages as well, but there are a lot of disadvantages as well. So what are those? Let's talk about development. Simple to develop, easier debugging, centralized management. Yeah, I think that makes sense, right? So all the layers, front end, middle tier, and back end. I would say middle tier, but middle layer, right? So front end layer, business layer, and the back end layer. All three things are together, so it's easier to debug. You can switch to another. When you are debugging, it flows from one layer to another layer to another layer. It's very easy to debug if you have a problem. Similarly, development is also easy. You don't have a lot of branches, checking a lot of too many people working on too many things. It's not like it's simple to work on, and everything is managed at one place, right? That's centralized management. Now, what is the con? Slower development for large teams, tightly coupled. Yeah, this is very, very important, especially with the modern way of development, because earlier days, the entire team is supposed to be used to be sitting at one place and they develop. Now the teams are geographically separated, right? So geographically separated, some people are in India, some people are in US, some are in Germany, some are in UK. I mean, like, people are distributed. So in that context, it's very difficult to implement such project, because if somebody is working, if people are working on the same thing, then there is a conflict, right? So a lot of it's very difficult to work. And also the layers, right? Business logic, the front end, the business layer, and the back end, they're tightly coupled. Initially they might start nicely, that okay, let's separate front end, business, and back end correct nicely. But if there is a bug and there's quick fix needed, suddenly somebody will start introducing some hacking kind of code, like okay, from front end directly jump to the database, right, with bypassing the business layer. You could do, because it's a single code base, right? So that's a challenge, and over a period of time this code becomes clunky and very bad, right? So this architecture actually it doesn't. There are certain advantages for maintenance, but lot of disadvantages for initial maintenance, but lot of disadvantages for long-term maintenance. If a bug is there, the code is convoluted, then it's very difficult to figure out. The second one is deployment. It's easy, like a one component, just put it. You don't even need ISO, just exe. Push the exe along with some DLS. It's easy. However, it's risky because you want to deploy an application and database. So let's say you just fix some spelling mistake, right, somewhere in the front end. Now you have to build the entire application and you have to follow the entire build process. Let's say you implement DevOps in this as well. Now the entire build process has to have been, it could take, the build could take, if it's a very big application, build would take 4 hours, 5 hours. Then, put it onto the production or testing, into the testing and then staging and the production. It takes a lot of time just for a single spelling mistake correction, right? So, it's very difficult or very slow to deploy thing. And also, you can't guarantee that, if you make a change in the front end, you can't guarantee that it could break in the back end, right? So because there are tightly coupled, right? So I'll talk about coupling later, but yeah, they're tightly coupled. Now, scalability. Well, you can scale it like we have seen in the previous diagram. You have one component, you can just scale it. You want another instance, you just start another instance. Like that, you can scale very easily. However, you cannot scale, because it's a very big application. Let's say you have a box, right? How many instances you can have? 3 instances, 4 instances. Then you need to go to another box. So, again, all of them needs to point to one database. Then it becomes very slow, right? So because there is only one database, so it's very difficult, right? So, when it comes to vertical scaling, yes, it is there. It's easy. When it comes to horizontal scaling, it's not resource efficient, difficult workload distribution. So what is vertical scaling and what is horizontal? Vertical scaling is nothing but, you have instances of the same application in one machine, right? So you have it's easy, right? So you can have an application is one instance, second instance, third database also point to that. Let's say you want to have the instance of this application on 3 machines. You can have them, but all of them have to point to the same database, right? So, and there is going to be conflict of the database, right? So workload distribution is also, it's not good. And also this is inefficiency, because you allocate the entire resources for one instance to another instance, even if it is like not used much, right? So that is a big challenge. You don't say, let's say there is not much focus on the business access layer. Only front end and middle layers are there, are being used much. In that context, you cannot just say, okay, I need 3 instances of this, 2 instances of that. You can't say that. You have to have the entire instance, right? So because it's a single bundle of things. That's what it is about scaling. Maintenance, like we talked about, simple to monitor, unified technology stack and all that stuff. Again, it's a disadvantage also. Let's say you want to, front end you want to use something else, and middle tier you want to use Java, back end data access layer you want to use something else, like PHP you want to use front end, or you want to do something like that. So in that case, you cannot do, because it's the architecture itself is forcing you to use only one technology, and also, even if for a small change, the entire thing application has to be built, which we discussed already. A lot of build time, and also refactoring. When over a period of time, the code becomes clunky and it's very difficult to refactor the code, because they're all connected. So well, if you touch here, it's going to break somewhere else. So yeah, changes affects many parts. Resilience. One good part is, if it fails, you can easily, the entire application fails, it will give a core dump, and you will say, okay, this is where you have the problem, right? But you cannot isolate this, like fault isolation is not there, like this is, let's say there is a problem with the UI. You have to use another UI and work with that. No, it's not possible. Once it is done, right? So that is the challenge with this application model. Organizational. So initial small, there is only one application, so learning curve would be easy. Whereas over a period of time, what happens is there are certain few people who knows the entire application, but rest of them kind of floundering because it's difficult to learn, understand from them, because a lot of complications happen slower because it's not like clearly separated, right? So that actually makes slower feature delivery and stuff like that. The cost, initially it is less cost, but long term there are going to be a lot of operational costs in maintenance. Small bug fix in the business layer may need repercussions on the front end as well as the back end, right? So because they're all again connected together. So that's pretty much the pros and cons of the monolithic architecture. So thank you very much. Let's see you in the next video. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.